All right, we're recording. This is lesson 3 in grade 12 essential maths vehicle finance units. Oops, I'm knocking my microphone over here, sorry. And the third lesson is on fuel economy. All right, a major cost of operating a vehicle is the fuel cost. I looked this up. This is the average in Manitoba today. The average in Manitoba today was 167.8, which means that I think it was, when I drove by, I think it was 167.9, which means that all of the discount places put together only brought the average down by 0.1. That's what that would mean, right? And this is weird to me. For years growing up, until about 10 years ago, maybe less, diesel was always cheaper than regular gas. It's still a little bit more. The average, I wrote it down here as 174.5. Anybody watching this video not in the year 2023, of course, these numbers are going to change. Heck, if you're watching this video tomorrow, the numbers are probably going to change. But that's where we're at right now. And for those of you, does anybody drive a vehicle that has diesel fuel? Yeah, diesel fuel is heavier fuel. It's more dense a liquid, and that means you can actually run a very large engine much cooler. Diesel fuel runs cooler, so things like big trucks, things like snow removal equipment and plows and backhoes and all the the construction vehicles, those things are all going to use diesel fuel. The drawback of that, you're probably going, well, why doesn't all cars use that? Well, the drawback of that is that when it is really cold outside, sometimes getting a diesel engine to start can be very difficult because the cold outside makes your liquid even more dense, and then it might actually not even vaporize, and then you can't start your vehicle. So that's the drawback. Diesel fuel is also quite a bit dirtier. It is far more polluting than regular gasoline. So diesel fuel is something that you don't see very often in regular cars. There are some. I actually was in Germany and I saw a diesel BMW. He drives a diesel. I drive a TDI. You have yeah, there you go, a diesel TDI. Okay, right on. So do they even make that anymore? Yeah, they do. Oh, okay. So yours, how old is yours? It's a 13. So 2013. So it's 10 years old. Oh, cool. All right. All right. Anyway, there's the two gas costs again. This is the one that most of us would care about. And let's think about what that means. That's in cents per liter. 167.8 cents per every liter. Okay? Yep. Now, different vehicles require different amounts of gasoline to drive the same distance. Fuel costs vary across North America and even vary within the same city, right? Some places will have discounts on their gas. Costco might be the cheapest gas you're going to find because at the end of the day, they don't really care if they make any money off selling you gasoline. They want your spouse or significant other to go into the Costco and spend a whole lot of money on their other crap while you're sitting in line waiting to get gas because there's always a lineup. That's what it's all about. That's why Costco even has gas. It's just an excuse to get you there so you can go spend money on other things. So if they don't make much on it, they don't really care. So I had that question this morning. It's like, how come Costco's cheaper? Well, it's because they're cutting out their profit on it. They're not making much.
Most of the profit comes actually from the Costco card, your membership.
The Costco membership itself. That's pure profit for them, I would think. Yeah. Okay. Any questions so far? Let's use some vocabulary here. Now, think about this. We need a way to compare how much gas you use. Now, if I said, well, I drove a great big bus today, and I drove it around for a while, and it only was $40 worth of gas, and somebody was driving a TDI or the little Honda or something, and they said, oh, I spent $80 on gas. Well, that's because the person in the Honda obviously drove a lot further than I did. So we need a way to commonly compare. We need a unit of comparison for how much gas we're using, and the unit we use is the number of liters of gas that you use to travel 100 kilometers. So that's our unit, liters per 100 kilometer. So don't think of this 100 as a number or as a measurement. It's a unit, liters per 100 kilometer. Thoughts?
Why is liters spelled like that?
Because the question that did not get picked up by the microphone, I would bet, is why do we spell liters with an RE the same way we spell meters with an RE? Because it is Canada, and this is a word from French. The metric system came from France, so we spell it the French way.
We don't pronounce it the French way.
Metre? Lettre? Litre? Liter? I don't know. Whatever. That's the way we spell it. All right, so 100 kilometers per, liters per 100 kilometers is known as the vehicle's fuel economy, also known, sometimes you'll just hear this word, the consumption. Like, your vehicle consumes gas, consumption. Now, what determines the fuel economy in your vehicle? Well, there's actually a lot of things. Obviously, number one is the type of vehicle you drive. And smaller, lighter vehicles will, of course, have a much better fuel economy and fuel efficiency than heavier, bigger engine vehicles. Also, newer vehicles, technology is always improving. Newer vehicles are better at consuming gas at a more efficient rate than older ones. Usually. There are some vehicles where the engine's been the same one they've been designing for 30 years and they're not changing. If it ain't broke, don't fix it. So that can be true too. Question?
Funny thing, before all emission standards, vehicles were actually more fuel efficient, and then once they introduced all that.
Yeah, but that's per the weight of the vehicle, and we just don't make vehicles that heavy anymore. So yeah. So yeah, fuel economy is still better. All right, anyway, type of vehicle is number one. And then the next one, of course, is how far you drive. Right? Obviously, if you drive, I commute from here to the, west end of town, so I'm going to use more gas than somebody who commutes from a few blocks away. After how far you drive, a lot of it comes down to where you drive. Think about commuting through the city. There's traffic lights every couple of blocks, right? You stop, you start, you stop, you start. That consumes a lot more gas than driving on the highway. You'd think, well, if I'm driving on the highway, I'm going a lot faster. Am I not burning more gas because I'm going faster? Well, yeah, you are, but you're still going further per the amount of gas you're using. So you get better gas economy, better gas fuel efficiency on the highway than you do in the city. Unless you drive like a maniac. And that's where this one comes in. How you drive. If you're one of those people as you're driving through the city where you step on the gas as hard as you can to get to the next light, and then you practically have to slam on the brakes. Anybody sitting next to you has their drink in their lap because you slammed on the brakes. And then the light turns green, so you accelerate really hard again, and then at the next light. If that's the way you drive, you are wasting so much gas money. And here's another thing. This is one of the great truths of how it works. If you want to think about people who drive in the city, they just have a heavy foot. They drive too fast. You're not, what are you saving? You get to the next light 10 seconds ahead of me. Yay, we're still not getting anywhere any faster. And you're just wasting gas. And on the highway, oh man, when I drive from here to Grand Forks, of course, from Winnipeg to the US border is 110 kilometers an hour now. You can go 110. But when you cross into the States, you can go 75 miles an hour, which is more like about 123 or 4 kilometers an hour. And the difference between how much gas I use at 120 versus 110 is significant. And whenever a politician even dares to say, well, we should think about maybe slowing down the speed limits on these highways, of course, that's political death for a politician. Nobody wants that. But at the end of the day, when they say, well, we've widened the highway, so we're going to raise the speed limit so people can get going faster, that is almost always them paying back the oil and gas industry for supporting them, because nobody wants speed limits higher like the oil and gas industry, because they know that you're using more of their product to do the same distance. Right? Think about it. From the US border to Grand Forks is pretty much 100 kilometers. So if I go 125 kilometers an hour versus 110, I will get there in maybe 5-6 minutes faster than if I'd have just gone 110 the whole way, and I'm using probably about 20% more gas. That's what I've noticed. It's significant how much gas you use. And of course, people who actually care about highway safety talk to an actual highway patrol police officer whose job sometimes involves pulling dead people out of their vehicles in whatever pieces they may be in. They will tell you the difference between a crash that happened at 100 kilometers an hour versus 120 is nothing to joke about. It is the difference between you could possibly survive this versus there is no way anybody is surviving this. So to make gas and oil companies happy, and people who just like to drive fast because they like to drive fast, we increase speed limits as soon as we make highways newer and bigger. But at the end of the day, we're making them less safe, and we are wasting money. There is nothing wastes money like driving fast. So drive fast, you waste gas. That's the reality. Okay, some of the other things, of course, might be, maybe one other thing here would be the condition of your vehicle. If you allow, condition of vehicle, if you allow your vehicle to get old and you're not servicing it regularly, you get gunk building up in the pistons, you get dirt and grit building up in all of the moving parts of the engine, and you just lose efficiency and you're spending more gas to drive the same distance. So there we go. There's the fuel economy factors right there. Here's the formulas. We won't kind of go through them. You can just kind of have a look at them, and we'll kind of look back to them as we need them here in the examples. Next, we're going to take a look at an EnerGuide label. The Canadian government puts together an EnerGuide label for all vehicles that are new, appliances, heating and cooling equipment, and even for new houses. You go up to a brand new house that's just been built, somebody will have inspected it, and they'll slap one of these EnerGuide stickers on it. And the EnerGuide sticker tells you a lot of things. This is the one that you'd see on a vehicle. This would be on one of the windows, stuck as a sticker to one of the windows of a vehicle in a showroom or on a lot where they're selling you a new vehicle. And obviously, number one is telling you what? Well, it's telling you that it's a gasoline vehicle. So number one is the vehicle, technology, and fuel number. So the text and related icon identify the type of fuel used by the vehicle. Right now, I can look at number one and say, aha, it's this icon here. So it's gas. If it was electricity, I think it's a little lightning bolt. And yeah, I think if it's a hydrogen vehicle, I believe it's an H+ for hydrogen. Okay. Next, number two, fuel consumption. So where's number two? There's number two right there, the big number. The fuel consumption number, this is a prominent combined fuel consumption, is the word we're looking for, rating, and separate city and highway fuel consumption rating. So the big number is the average. I don't quite know does that actually work for an average? 10.7 plus 7.4 added up and divided by 2. Well, they just rounded down to 9.0. I guess it should technically be 9.1. But there we go. They rounded it down. That's fine. They're trying to make it, well, actually, they're trying to make it better than it really is. But basically, again, remember I mentioned a minute ago, it is actually, you are more efficient on the highway driving than you are in the city. Smaller cars, that difference is not as big, but the larger the car is, the better you do on the highway versus the city. So there we go. This is combined average. If you do a lot of driving in the vehicle that this sticker's for, but you always stay in the city, this is probably more the number you should be looking at. If you live out in the country and you don't come into the city very often, this is the number you should be looking at. Okay, number three. Well, you never know. Maybe this vehicle might be bought by somebody and then they move to the United States, and then you have to think of totally new numbers. Kilometers, liters, what? That's right. The Americans do not use the metric system. Our neighbors to the south still use the imperial measurement system. So number three is for them. Number three is the fuel economy expressed in miles per imperial gallon. And for those of you who remember, didn't mean to bring that up. 1 mile is approximately 1.6 kilometers, roughly. Okay. Number 4, what's number 4? Number 4 is this big number here. If you drive an average annual distance of about 20,000 kilometers, and I assume probably combined city highway, that's what you would expect to pay every year in fuel costs for this vehicle. So let's see, where's the blank in this one? I didn't have an answer key for these blanks. This morning we kind of had to figure them out. This is an estimate based on the combined fuel consumption rating for 20,000 kilometers driven and the fuel price indicated. Of course, that's going to change from year to year as the gas price goes up and down, but that's based on the year they made the sticker, I suppose. Vehicle class range. So this shows the best and worst combined fuel consumption ratings of vehicles in the same class. So say, for example, that this was a sticker, number 5. Say this was a sticker for a, well, let's use my vehicle as an example. Say this was the sticker for my 2018, it was still sort of new when I bought it, so it still probably had the sticker, I can't remember. My Toyota RAV4. What else would be in its class? Well, the Honda CR-V, maybe the Ford, what's the Ford? Escape, thank you. What else? The Nissan Rogue, there you go. So those would all be comparable, and their ranges, there's the best, there's the worst. Bet you that one's the Cadillac Escalade or something. Oh no, I guess they have a smaller. The Escalade would be more like a Toyota 4Runner because it's very big. What's the smaller? Cadillac has a smaller SUV. I forget what it's called though.
Yeah, it's the same one as the Chevrolet, no, I've lost it.
I can't remember what it's called either. But
Equinox. It's the same as the Equinox, which is the same as the GMC Terrain, which is...
they all have the same chassis basically, right?
CTS,
Yeah.
I think is what they call it.
Is that what it is? The Cadillac CTS?
Unless it's CTS.
I don't know. You might be right. Anyway. Moving along, number 6. This isn't such a big deal here in Manitoba, but there are some places, I don't know if there's any in Canada, but there certainly are some places in the States where you pay extra taxes on vehicles if they pollute more than others. So that's why vehicles have to have a CO2 and a smog rating. So the numbers here, it's like a little scale. Here are the vehicle's tailpipe emissions. It took us a while to figure out what this word was. And I think I've spelled it right. 1 M2 sounds right. So the tailpipe emissions of how much carbon dioxide and smog-forming pollutants rated on a scale from 1, which would be the worst, to 10, which would be the best. The CO2 emissions in grams per kilometers driven are shown on a bar. So you take a look at the sticker, and there you go. There's the bar. So this vehicle is a 6, 1 being the worst, 10 being the best, for both your carbon dioxide and your smog rating. And then finally, number 7 is a QR code, where you can get more information that would tell you a little more detail about all the numbers on the sticker. And I think this would take you to the Canadian Government EnerGuide website. So that's what the sticker looks like if you're trying to shop for a vehicle and you're thinking about the fuel economy. You have to kind of look at this sticker and understand what all the things mean. All right, so let's do some math. Example 1. A car requires 52 liters of gasoline to fill the tank. If the cost of gasoline is 121.9 cents per liter, calculate the cost to fill the tank. Step 1, change this number to dollars per liter. Cents are interesting. We always put the cent symbol after the number, whereas a dollar sign always goes before. But anyway, what do you have to do to a number to change it from cents to dollars? You divide it by 100, exactly. So you divide it by 100, and you could even say that you're dividing by $100, or sorry, I meant to say $100 or cents per dollar. That's what I meant to say, thank you. Having trouble talking today. 100 cents per dollar, and then since you're dividing cents by cents, the cents cancel, and you end up with dollars per liter. And here's where this is going to be confusing for some people. Some of you, okay, listen to me carefully. Every other time this year, I've always said round money to cents. Why, Mr. K, are you keeping 3 decimals here? And the reason is because maybe you weren't listening carefully. I always said round your final answer to cents to 2 decimal places. This isn't my final answer yet. I still have to do a calculation with this number. Don't round it now. Okay, so it's $1.21.9 per liter, and I'm buying 52 liters, so it's $1.219 per liter times 52 liters. And those of you who remember from previous grades, you can liters on top, liters on the bottom, they cancel each other. And I'm left with a number in dollars, and when I punched this earlier, somebody could double check the button punching to make sure I got this right. It's $63.39. Oh, remember when gas was only $1.21.9 and you could fill your tank for $63? My word, that seems like a lifetime ago. But there we go. Who knows? It could go down again. Certainly it went down a lot during the pandemic. Any questions on how I did that calculation? Again, it is key that you don't round this number until the end. You round to the nearest cent at the end. Do not round the number of cents per liter when you change it to dollars per liter. All right. I had some people this morning who did not know the answer to this. I know some of the people in the room will know the answer to this. But does everybody know what an odometer is? So an odometer is basically one of these things. See that little digital number there? Most of them aren't digital. Most of them are a little like a little wheel of numbers. What do these digits represent? These ones are all in kilometers. Well, that one's in miles. But these all represent how many kilometers, or in this case miles, the vehicle has been driven overall. Now, some of the fancier vehicles here, like the ones that are digital, you can press a button and it'll just change to how many you've driven in this trip. But for the most part, they all just say how many kilometers are on the vehicle in total since they first built it at the factory. So that's what your odometer means. Yep. So from here, let's say I took a trip and this is what my odometer read when I left. There's what it read when I got home. How far did I drive? I take the final reading and I minus the initial reading. And that will give me, I've already done this calculation, and that's 776.9 kilometers. Somebody asked me this morning, how come you didn't put the zeros in front? Well, because those zeros don't mean anything, right? They're just there because there doesn't happen to be a number in the 100,000s yet. This is still a pretty new vehicle. It's only got 12,000 kilometers on it, right? Zeros in front of numbers don't mean anything. That's why James Bond never impressed me. He's just a 7. And only a couple people got that joke. All right, example 3. Oops, I already have this one filled in. Here, let me erase it to start over. You didn't see that. Okay, next. Which car has the best fuel economy? All right, which car has the best fuel economy is whichever one is the smaller number. So best is smallest. So car B, because it uses the least liters of gas to drive 100 kilometers. Car A takes 8 liters when you go 100 kilometers. Car C takes 11.5 liters to drive 100 kilometers. Car B, 6.8 is less than those two. So that's something you have to remember. Fuel economy, the best is the smallest, not the biggest. Any questions about that one? All right, example 4. A car, well, again, we're going to stick to metric in this course. A car with a full tank of gas was driven 572 kilometers before stopping at a gas station, and then it requires 41.2 liters to fill the tank. So step 1, calculate the fuel economy. Okay, so now before I start, I've already got the calculation done here. There's a little mini calculation. Remember that fuel economy is liters per every 100 kilometers. How many 100 kilometers are there here? Well, if I had 500 kilometers, that'd be exactly 5 of them. If I was breaking that into groups of 100 kilometers, that's 5 groups. But this is 572, so this is 5.72 100 kilometers. So I take how many liters, divide by how many hundreds it is, And again, all I did to this number was I divided it by 100. And that gave me 7.2. You usually round fuel economy to 1 decimal. I know most of the stuff we do in this course, we use 2 decimal places, but every fuel economy sticker I've ever seen, 1 decimal is all you get. Okay, now calculate the cost of fuel for the trip. If the cost per liter was 133.9, so the first thing I did was I changed the cents to dollars, and again, I did not round this number. And then I times it by how many liters I bought, and then I rounded this number because I think this had other decimals on it. So 55.17 is my example 4 number. All right, one last example. Gina travels a total of 350 kilometers in the city and 200 on the highway during 1 week of driving. Her car has a fuel economy of 10.5 liters per 100 kilometers in the city and 7.4 liters per 100 kilometers on the highway. Gasoline costs 121.9 cents per liter. Again, oh, those were the days. How much, or how many liters of gas did she use in the trip? So I have to do these separately. In the city, she drove 350 kilometers. That's 3.5 hundredths. I just divided that number by 100. Then I take that and I times it by the fuel economy, and then the 100 kilometers and the 100 kilometers cancel, and you got 36.75 liters. Her highway driving, well, 200 kilometers, divide that by 100, you get 2, so that's 200 kilometers, times 7.4 liters per 100 kilometers. Again, those units there cancel. And I'm left with liters, 14.8. Total that up, 51.55 liters. Now let's calculate how much she spent on the trip. So the first thing I did is I took 121.9 cents, divided it by 100, but I didn't round it because that's still money that counts. That 0.9 cents of a liter will add up when you buy lots of liters. So $1.219 per liter times 51.55 liters, and that trip cost $62.84. And now it's your turn to try some of these calculations. You are now going to work on worksheet 3B in your workbook.